graph the polynomial function. The strategy for graphing the polynomial function: we find the x and the y intercepts of the graph, determine the end behavior, determine the multiplicity, and then draw a graph as a smooth, continuous curve. Now, multiplicity. What is multiplicity? We look at this page. The multiplicity is a number on the top right corner outside of your parenthesis after you factor out your polynomial function. For example, if you look at f of x function here, once I factor out the function itself, I have a two-factor form. So from here, the multiplicity number is on the top right corner. In other words, this is a 1, this is a 1. So by using the zero factor theorem, we solve for x. So x equals -2. The multiplicity is 1. When x equals 2, the multiplicity is 1 as well. Let me put an equal here. So when the multiplicity number is an odd number, odd multiplicity, that means at that point, the graph will crosses the x-axis. Crosses the x-axis. We do the other example. G function has x plus 2 times x plus 2 times x minus 2. Now these two, they are the like term, right? So we can combine these two into the x plus 2 to the power 2 and multiply with x minus 2. Now this number is the multiplicity of 2. So that means when I solve for x, x is equal to -2. So the multiplicity is equal to, is an even number. And now the solution, x equal to, this is x equal to. The multiplicity is just 1. This is 1. So when you have a solution of, or when you have the root of x, the multiplicity is an even number. That means the graph will passing through x-axis by bounces or touches the x-axis. The x-axis. It could be touch above or touch below of the x-axis. So determine the multiplicity, we need to factor out the function and then look at the top right corner outside of the parenthesis. What is the number it has? And that number will help us to determine when the curve go to the x-intercept point, does the graph touches the x-axis or bounces the x-axis or crosses the x-axis? So now we go back to look at the function from our slide. We have to graph this function. The function has x power 3 minus 4x. This is a polynomial. So we need to find the x-intercept. Finding the x-intercept, we let a y equals 0. Right? So the x-intercept, we let a y equals 0. So here on this slide, it shows us the x-intercept point. You let a y equals 0. And then you take out the common factor is 2. So bring the the common factor is x. So bring the x to the outside. The first term has x squared left, and the second term has a 4 left. Now, here we can continue to split into the x plus 2 multiply x minus 2, or I'm going to do the work here. X times x squared minus 4 equals 0. So from here we can solve for x. I can treat this x just like x minus 0. So this is x equals 0. The multiplicity is 1 because I only have power 1 here. This form x squared minus 4, again, the power on the top right corner outside of the parenthesis is 1 as well. So when we solve for x, we get x squared equal 4, which is x equal 2 or x equal negative 2, right? Two solution. Now both of the solution, the multiplicity is 1. Multiplicity is equal 1 because the power on the top right corner outside is 1. So although we solve for x has two solutions, but both of the solution, the multiplicity, they are 1. So we found the 3 rule on the x-axis. Now finding the y-axis, we did the x equals 0. So y-intercept, we did the x equals 0. So that means I substitute the 0 back to the function. So I get a 0 minus 0 is 0. So this is your y-intercept. Now we need to determine the end behavior. End behavior, the highest degree power term here tell us is a degree 3, and this is a positive odd function, right? It's a positive odd. So I know the positive odd function has a graph turned to this direction. So as x approaches to positive infinity, f of x approaches to positive infinity. As x approaches to negative infinity, f of x approaches to negative infinity. And the last step is turning point. The highest degree power of this one is power 3. So I know on the curve of this function, on the graph of the curve, will has 2 turning points. So now I'm going to sketch the graph on the side here. So the x-intercept, we have 0, 0. This is 1 point. Let me use another color. So this is 1 point on the x-intercept. The other two x-intercept is 2, 0, right? This is 2, 0, negative 2, 0, and this point has 0, 0 on the x-intercept. So we have 2, 0, and a negative 2, 0. The y-intercept has 0, 0 as well. So your y-intercept has 0, 0. So this would be y-intercept as well. End behavior, we know the graph has the end behavior tend to this direction. Since each of the x-intercept, they all have the multiplicity is 1. So we know the graph, they will cut through these 3 points when the curve come to near to the x-axis here. So now we can sketch the graph, combine all the points here. So it will cut through this point at x equal 2, and then it will change the direction, go back to hit the x equal 0, and then you will change the direction to hit the x equal negative 2, and then drop down on the quadrant 3. So this would be pretty much the graph to represent the function f of x. Of course, you can use the calculator to sketch the graph, and you can find this point by using the table on your TI-84. But I'm not really picking on those parts. As long as you can perform the graph as a smooth curve, you understand how to find the x-intercept and the y-intercept. You understand what is the multiplicity? That's the part I'm looking for. But the graph, if you do the graph manually, that will be the graph overall picture it looks like. Now we look at this example. You have to match the polynomial function with the graph shown below. So the g function has a negative, right, x minus a, so it has one solution is x equal a. From here, this is x equal a. When x equal a, the multiplicity is 2. So you have the multiplicity is equal to x minus b, that means x equal b. The multiplicity is 1 because here has just power 1. When x equals c, the multiplicity is 1 as well. Now, in front of the g function has a negative sign, that means this is negative. This is a negative polynomial function. How can I tell what is the highest degree power? This is power 2, multiplied by power 1, multiplied with another power 1. So we'll have 2, 3, 4. So the highest degree power of this function is x power 4. We add a power. So that means you have a negative even function. So the negative even function, you will have the both end the behavior, they will facing down. So if you look at the option here, we know this would be the solution. And it passing through A. When the graph comes to A, because the multiplicity is 2, so it touches, right? Touches the curve will touches to the x-intercept when x equal a. When the curve comes to the b, it crosses the b, it cut through the b. When the curve comes to the c, it cut through the c. And when they come to the a, it touches below the x equal a. So this will be the correct graph you have to select. Now we do the other example here. We need to find the zero of the polynomial function and then state the multiplicity of each. State whether the graph touches the x-axis and turns or crosses the x-axis at each 0, which means we have to state it touches or crosses. Now, the highest degree power of this one has x power 4, right? So it's a polynomial function. When I look at this function, I know I have to take out a common factor of x power 2. So we do that first. Bring the x squared to outside. The first term, we still have x power 2. The second term, it turns to minus 7x. And the last term has a 6. Now, inside this 3, we can continue to factor out. So the factor form of this 3, it has x times x, 1 and 6. So the product of 1 and 6, it will go back to 6. The middle term has negative 7, that means both of the numbers carry the negative sign. So when you sum these two, you will have minus 1x minus 6x, it turns to the minus 7x. When you product the last two, you will get a positive 6. So this is a vector form, the complete vector form we have here. Let me write down here, x squared times x minus 1 times x minus 6. So from here, we can solve for x by using the zero factor theorem. Now x squared, this is the same way I can write into the x minus 0. And then I bring the power 2 to the outside. So that it's easier for you to see the multiplicity is 2. So this is the multiplicity is 2. When x equals 0, right? and multiplicities too.